Huh. Unit 1, and we are going to do the crash course on four of units of electronics. First was Unit 1, so assignment written by you only, by the students. I'm just going to explain it again to give you overview of the electronics subject. Now draw a circuit diagram of JFET common source amplifier using a small AC signal. Drive the expression for voltage gain. Now you can see on the screen it's the circuit diagram of JFET. First first part has been covered by just drawing the circuit diagram and using the small signal AC module. Small signal AC module is this. Okay. By using it, we have to find the voltage gain, and that is the voltage gain. Voltage gain is equal to ID current flowing through the circuit equal to mu VGS divided by RD plus RL. RD plus RL you can see over here. This RD plus RL. Okay, and the current is minus of mu UG divided by RD plus RL. VDS is equal to ID into ID is flowing through the RL, is therefore ID into RL, and we get minus of mu G into RL divided by RD plus RL. AV is the voltage gain, which is nothing but what is the output voltage? We have output voltage as a VDS divided by input voltage VGS. We got this. Mm, when we divide this above equation, minus mu VGS divide into RL divided by RD plus RL, divide by VGS, the VGS get cut out and remains this. Now mu is nothing but GM into RD. Okay, it's a amplification factor which is nothing but GM into RD. GM into RD into RL divided by RD plus RL is the voltage gain. Okay, even if you can start over, sorry, stop over there. Small explanation is needed here, and that's given above. It's better to write point wisely so that you can understand. Now, in common source amplifier, current RD flow through the RS and develops a reverse bias voltage at the gate. The presence of RS result in the positive voltage Vs due to the voltage drop at ID into RS. No DC current flows through the RG. Therefore, VG voltage at gate is equal to 0. Since voltage is gate equal to 0, we have VGS equal to VGS minus VS. VG is equal to 0. We will write VG equal to 0. Vs, as we have described above, is nothing but minus of ID into RS. Therefore, VGS is nothing but minus ID into RS. The capacitor is to block the DC signal from affecting the gate bias, and the input AC signal versus appear to be at the RG. Okay. Same way, capacitor 2 is used to block the DC component of signal from going to the output. Next question we have, explain the term of holding current. Forward current rating for SCR. An SCR has a current fusing rating given 70 ampere square. Determine the highest sugar current values an SCR can be withstand for the 20 period of the 20 millisecond. Now, holding current, maximum anode current that SCR can handle safely when it's on state. Okay, that explanation and that's a definition is written over here. Okay, it is specified by the conducting angle alpha and the temperature. Now, second word it says forwarding current. Wait, something is wrong. holding current is return. Okay, I'm sorry. Forwarding current is maximum anode current that SCR can handle safely in on state, where holding current is to hold SCR. The minimum anode current beyond which SCR will turn off. कितना minimum current flow करना चाहिए to hold the SCR on. Okay, after that it will be turn off. Okay, beyond it will be turn off. The equation of holding current is written. Forwarding current is written. Holding current is written next. Now the question was in numerical form that circuit fusing rating is 70. Sorry, current fusing rating is 70 amperes a square second. Time is 20 millisecond. Now current fusing rate is equal to I square T. I square T, this is 70. We have to find I square. T is 20 millisecond. I square will be equal to 70 divided by 20 millisecond, which is nothing but 3500. I under root of I is nothing but 49.17 ampere. 49.16 ampere. Next question we have, describe the application of JFET as a series switch in an analog multiplexer. Now the series switch circuit is this, where you can see that RD is in series with the input Vcon. When Vcon is likely to close the switch, V output is equal to V input. And when Vcon is more negative, the JFET is open switch and V output is equal to 0. When the switch is open, no current, no signals reach the output, and when signal is closed, the most of the current signal reach to the output. The on-off ratio of switch is defined as the maximum output voltage divided by minimum output voltage. The JFET is a analog multiplexer. You can see in the diagram there are three JFETs and three are attached at source and given RD. Okay, and three waveform are given to the every JFET. Whichever JFET is on, that waveform will appear at the output. Next question. An N-channel JFET has gate current 1 nanoampere. When reverse voltage gate is 20, what is the input resistance of JFET and what is the ohmic resistance of JFET? So very small. VG is equal to VGS is equal to nothing but input resistance R in VGS divided by IG, and we both have, we will find what is the input resistance. Ohmic resistance RDS is equal to VP divided by IDSS, and that value also given into the question. We can easily calculate what will be the ohmic region. Next numerical question is half wave rectifier using a CR against adjust to have the gate current of 1 milliamp. If sinusoidal voltage is 200, peak is applied to circuit when the conduction angle is 150. Find the forward and backward voltage and average output voltage. Now here Ig is equal to 1 milliamp, peak Vp is 200, and the conduction angle is 150. The conduction angle is equal to 180 minus theta, that is theta is equal to, again reverse में 180 minus 5 Therefore, theta will be, we will get 30. The forward breakover voltage is equal to V is equal to Vp sine of theta. Theta is nothing but 30, which we calculated over here. And 200 Vp into sine of 30. Sine of 30 is nothing but half. So we will get V is equal to 100. Now average output voltage, formula is average output voltage is equal to Vp divided by 2 pi 1 plus of cos of theta, that is Vp is nothing but 200 divided by 2 pi 1 plus cos of 30 degree. We get a voltage average equal to 59.25 voltage. As explain how SCR is used as full wave rectifier. Drive expression for its average output voltage and current, and how it differ from the ordinary rectifier. Now here is the circuit diagram of SCR as a full wave rectifier. Okay, now working conduction angle change by the changing gate current, and we will have this cause the upper secondary end positive and lower secondary end negative. This causes SCR to conduct. Above SCR 1 will conduct and below SCR 2 will be is off. The voltage appear at RL. During the negative half, it reverse bias. SCR2 will be conduct and SCR1 will be turn off. Okay, but we will get the wave in both in positive cycle also in negative cycle of the primary also. Now let's applied voltage is equal to Vp into sine theta. Now alpha is the firing angle. We get V average is equal to for alpha to 180 degree Vp sine theta, and Vp is a constant value will be taken out. Integration alpha into 180 degree sine theta d theta, which result into minus cos theta from alpha to 180 degree. If we write cos of 180 degree is nothing but minus of 1, that result into average output voltage is Vp divided by pi 1 plus of cos of alpha. This value is double of the half wave rectifier. What is the difference between the normal rectifier and SCR rectifier? In SCR rectifier, angle of conduction can be changed by adjusting the gate current. Therefore, SCR control power feed it to the load. In ordinary rectifier, this control is not exist. Now, explain working of SCR and explain working of half wave rectifier using SCR. Drive the expression for DC output current. Now, construction and working of SCR, first we have to explain, and then we will going to drive the expression for the half wave. Construction, as you can say, it's a PN junction, that is there are three junction. Okay, one P side taken as a anode, second N side taken as a cathode, and the near to the cathode P side is taken as a gate. This is can be equivalent to the two P or NPN transistor combination. You can see equivalent circuit of SCR. Okay, now working of SCR is connected. Load is connected in series with the anode. The anode always kept positive potential with respect to cathode. There are two method to turn on the SCR. Okay, when the gate is open, there is no voltage is applied to the gate junction, that is this J2. Okay, is reverse bias, which junction J1 and J3 are formed forward bias. Consequently, No current flows through the load RL, SCR is cut off. However, if the applied voltage is gradually increased, a stage reached when the reverse bias junction J2 break down and the SCR now conduct heavily and is said to be in an on state. Okay, this voltage, heavily conduct voltage, forward bias voltage is called breakover voltage. When the gate is positive with respect to cathode, if we supply a small amount of positive voltage potential to the gate, the J3 is forward biased and J2 is reverse biased from N type. Okay, and what will happen? It will start before the breakover voltage. Okay, there are two ways to turn on the SCR, but there's only one way to turn off SCR by reducing the anode current. Now working of the SCR as a half-wave rectifier. This is the circuit diagram of SCR as a half-wave rectifier. And derive this expression, we have written the expression. During the negative cycle, SCR will conduct, and during the positive cycle, SCR will not conduct. During the positive cycle, SCR will conduct. We will get only half cycle of the input. Okay, the expression for the output, average output is equal to 1 upon 2 pi 180 degree, pi to 180 degree Vp sine theta. Now this Vp is a constant value, Vp will taken out. Integration of alpha to 180 degree sine of theta result into minus cos of theta alpha to 180 degree. 180 degree is nothing but minus of 1, therefore minus minus get plus 1 plus of alpha, cos of alpha is equal AB is equal to Vp divided by 2 pi 1 plus cos of alpha. Since AB is equal to this, current average current is equal to AB divided by RL, AB divided AP divided by 2 pi, Vp divided by 2 pi RL 1 plus of cos of alpha. Now here is a numerical problem. Self-biased circuit has RD 5.6 kilo ohms, RS 450, VD 25, VD ID 2.5. Find the VG, S and VDS. Now VGS formula, as we know in JFET, is equal to minus ID into RS. Okay, ID is given, RS also given. We can easily calculate VGS. Okay, and this VGS is used in further. VDS is equal to VD minus VS. VD is equal to VDD minus RD, and VS is equal to ID into RS. VDS will be calculated and this finished up. Again, it's a numerical problem. Okay. Explain the use of JFET as a voltage control resistor. When the JFET is in the ohmic region, it acts like a voltage control resistor, that is VRA. Now for this we have, when we calculate ID versus VGS,